In this video, we will discuss about characteristics of transistor in common base, common emitter and common collector configuration. We will also discuss about the current gain alpha in common base configuration, the current gain beta in common emitter configuration, and current gain gamma in common collector configuration, and we will also discuss about the relation between alpha beta and alpha gamma or beta gamma. In transistor characteristics, we basically have two characteristics. One is your input characteristics, another one is your output characteristics. What we basically found out in the transistor characteristics, we found out basically the resistance, the input resistance in input characteristics and the output resistance in the output characteristics. How will find out the resistance? If we plot the graph between the voltage and current, from the voltage and current graph, we can find out the input resistance by dividing the voltage and current. We will find out the resistance. If it is for the input, it is called input resistance, and if it is for the output, it is called the output resistance. First, let us discuss about the characteristics of transistor in common base configuration. In common base configuration, the base is common to the input and the base is also common to the output. That is, base is connected to the emitter in the input and base is connected to the collector in the output. So in the input characteristics, we basically draw a curve between emitter current and emitter base voltage. This is the, in x-axis you will take the emitter base voltage, and in the y-axis you basically take the emitter current. And the emitter base voltage basically is of the order of in the order of millivolt, and the emitter current is of the order of milliampere. So you plot the graph at constant collector base voltage. This is the graph for the at constant collector base voltage 0 volt. This will be the shape of the graph, and this will be the shape of the graph for constant collector base voltage 10 volt. So the curve between emitter current and emitter base voltage at constant collector base voltage, it is called your input characteristics. And I have told you, in input characteristics you basically find out the resistance, input resistance. So input resistance Ri will be equal to delta V EB, EB for emitter base voltage, and delta IE for the emitter current at constant collector base voltage. Then what is the output characteristics of the transistor in common base configuration? For the output characteristics, this will be the nature of the graph for the output characteristics, and this is the curve between collector current and collector base voltage. In the output you have collector base voltage and you have collector current. Okay, this is basically from the biasing voltage, DC voltage, and the collector base voltage is of the order of volt. You supply 1 to 2 volt to the collector base and you find out the collector current, which will be in milliampere. And here you have to keep the emitter current constant. That is, in the input you have to make constant the emitter current, and you will plot the output characteristics at various emitter current. This is the nature of the graph or output characteristics curve at constant emitter current, that is 0 milliampere, and this is for 1 milliampere and this is for 2 milliampere. So throughout the experiment, what you do, you make the input current, that is the emitter current, constant, and you vary the collector base voltage, and you measure the corresponding collector current, and this will be the nature of the graph for the output characteristics. So curve between collector current and collector base voltage at constant emitter current, it is called the output characteristics or output resistance. So output resistance, you may represent it RO, that is equal to delta VCB, collector base voltage, change in collector base voltage to the change in collector current, and this is at constant emitter current. Now let us discuss about the current gain, that is alpha. So current transfer characteristics, the current gain, or it is called the current transfer characteristics. So in the input you have emitter current and in the output you have collector current. So if you plot a graph taking emitter current along x-axis and collector current along y-axis, then it will be a straight line. And from this straight line you can make the or find out the slope, that is the slope of this straight line will be equal to this value, change in collector current to the change in emitter current, and this will give you the value of alpha, that is the value of current gain in common base configuration alpha will be equal to delta IC divided by delta IE. Remember, when you do this experiment, you have to take the emitter current of the order of milliampere. You basically give 10 milliampere, within 10 milliampere or 15 milliampere, and you will get the current in the output or the collector. It will be around within 10 milliampere. That means the current in this collector will be less than the current which you give in the input. Now we'll discuss the second characteristics curve, that is the characteristic of the common emitter configuration. So in common emitter connection of the transistor, the emitter is common to base and also to the collector. In the input you give the voltage along the base emitter junction, and in the output you give the biasing voltage, that is DC voltage, to the collector emitter junction. So what will be the input characteristics? As I have told you, the input characteristics is the curve between voltage and input voltage with the input current keeping the output voltage constant. So here what you do, you keep the collector emitter voltage constant, and this will be the nature of the graph when the collector emitter voltage will be equal to 10 volt. This will be the nature of the graph, and when the collector emitter voltage is equal to 1 volt, this will be the nature of the graph. So keeping the output voltage constant, if you vary the input voltage, the input current will also vary. And remember, in case of common emitter configuration, you take the base emitter voltage of the order of volt. As I have told you, it is 0.7 volt. For germanium, basically you will get here the up to this there is cutoff voltage. Then you will find the rise in current, and you give the voltage of this order, that is about 5 volt. You give in the input about 5 volt, and in the current, in the input current, that is the base current, it is of the order of microampere. Remember, you connect a microammeter here in the input, so that you will get current of this order 1, 2, 3 microampere. So what will be the input characteristics for the common emitter configuration of the transistor? The curve between base current and base emitter voltage at constant collector emitter voltage, it is called the input characteristics or input resistance. And the input resistance Ri basically written as delta VBE that is base emitter voltage, change in base emitter voltage to the change in base current at constant collector emitter voltage. This will give you the input resistance, or what you say, the graph is called input characteristic graph. As I have told you, for the output characteristic, you keep the input current constant. Here the input current is the base current, so you keep the base current constant and you plot the graph between the output voltage to the output current. In the output, you have output voltage collector emitter voltage, and in the output current is the collector current. So if you plot the graph between collector emitter voltage with the collector current at constant base current, then the graph so obtained is called the output characteristics, and from this graph you can find out the resistance, output resistance. And this will be the nature of the graph. This is the graph for the base current 5 microampere. This is the graph for the base current 10 microampere. In this way, this will be the graph for the output, the input current 15 microampere. And you basically give the output voltage here of the order of volt. You give 0 to 1 volt, and in the output current you basically get current of the order of milliampere. You connect a milliampere to find out the output characteristics, and you will get current of this order 1 milliampere, 2 milliampere, 3 milliampere, like this. In practical you have to remember this, because it is very important to know which how much or the current, order of the current and the order of the voltage. Otherwise your transistor will not work. So to find out the output resistance RO, you only divide voltage by current, and this is delta VCE to delta IC at constant IV. And in common emitter configuration, you have current gain beta. We basically take current gain beta, and the current gain can be measured by plotting a graph between input current, that is the base current, with the output current, that is the collector current. So this is the, in the x-axis you have to take the base current, which is of the order of microampere, and you give current of the order of 100 microampere, like this. And in the output you will get collector current of the order of milliampere, and this is of the order of 10 milliampere, like this. That is why I have taken here 2 milliampere, 4, 6, 8. So in this way you will get a straight line. Your the graph will be a straight line if you plot the base current with the collector current, that is the input current with the output current. This will be a straight line. And always remember, the output current is less than the input current, and if you find out the slope of this straight line, you will find out the constant factor beta or the current gain in common emitter configuration, that is delta IC divided by delta IB. The third characteristics is the common collector configuration of the transistor. In common collector configuration, you have also two characteristics: input, output, and your current transfer characteristics. And here the current transfer characteristics is gamma. Then now let us discuss what is the input characteristics and output characteristics of transistor in common collector configuration. The curve between base current and collector base voltage. Remember, in common collector, you have in the input you have base current, and in the output you have collector base in the output you have to keep the collector emitter voltage constant. For the input characteristics, you keep the output voltage constant, and you draw the characteristics curve, voltage current curve for the input. And in the input you have collector base voltage and you have base current. So the curve between the base current and collector base voltage at constant collector emitter voltage is called the input characteristics. You see, if you plot the graph and you basically take in case of common collector connection of the order of volt, you see I have taken here potential, that is input potential of the order of volt 1 2 3 4 5 6 volt like this, and the current, the base current is of the order of microampere. You connect a microammeter in the input and it will be of the order of 20 40 60 80 100 like this. So at a collector emitter voltage of 2 volt, you keep the collector emitter voltage constant, that is 2 volt, then this will be the characteristics curve. This will be the characteristic, and from this characteristics curve you can find out the input resistance. The input resistance Ri will be equal to delta Cb divided by delta Ib at constant collector emitter voltage. And remember that it is different from the common base or common emitter circuit, and this difference is due to the fact that the input voltage, here the input voltage is collector base voltage, which is largely determined by the value of the collector emitter voltage. That is why the characteristics curve for common collector configuration is quite different from common base and common emitter circuit. Now let us discuss about the output characteristics of common collector configuration. As I have told you, this is the variation of voltage and current, output voltage to the output current. In the output you have collector emitter voltage and current is your emitter current, and you have to keep the input current constant, and here the input current is the base current. So Ib equal to constant, and this will be the nature of the characteristics curve at different input current, that is Ib. For Ib 0 microampere, this will be the nature of the curve, and this is for 20 microampere, this is for 40 microampere like this. So curve between emitter current and collector emitter voltage at constant base current is called the output resistance or output, and it is called the output characteristics curve. And mathematically you can write Rho, that is equal to delta BCE divided by delta IE at constant IB. And I will find out the current gain. As I have told you, the current gain means you have to plot the graph between input current to the output current, and here the input current is your base current and the output current is your emitter current, and the base current is of the order of microampere and the emitter current is of the order of milliampere. If you plot a graph between the base current and the emitter current, it will be a straight line, and the slope of this straight line will give you the current gain, that is gamma, which will be equal to delta IE divided by delta IB. Now we'll find out the relation between alpha, beta and gamma. First we discuss about the relation between alpha and beta. We know current gain in common base configuration alpha is equal to delta IC divided by delta IE. So delta IC will be equal to alpha into IE. Suppose this is equation number 1, and in case of common emitter configuration, the current gain beta is equal to IC divided by IB. So IC will be equal to beta into IB. Suppose this is equation number 2. Then what will be the emitter current? The emitter current is equal to the collector current plus the base current. And if you divide beta by alpha, you see beta is equal to IC divided by IB and alpha is equal to IC divided by IE. So if you divide beta by alpha, IC will cancels. So it will be equal to IE divided by IB, and IE is equal to you keep I here and you write IB from this equation 3, that is equal to IE minus IC, and you divide IE in the numerator and also in the denominator. If you divide it, then this will be equal to 1 divided by 1 minus alpha. So if beta by alpha is equal to 1 divided by 1 minus alpha, then beta will be equal to alpha divided by 1 minus alpha. So this is the relation between alpha and beta. Now we will establish a relation between alpha and gamma. We know current gain gamma is equal to the change in the output current here is your emitter current and the input is base current IE divided by IB. Suppose it is equation 5. So gamma divided by beta is equal to IC divided by IB. So if you divide the beta, IB will cancels. So this will be equal to IE divided by IC, and IE is equal to IC plus IB, because emitter current is equal to collector current plus base current and divided by IC, and this will be equal to, if you divide in the numerator and denominator IB, this will be equal to IC divided by IB plus IB divided by IB divided by IC divided by IB. So that will be equal to beta plus 1 divided by beta. So gamma will be equal to 1 plus beta. So this is a well-known formula between gamma and beta. But gamma is equal to 1 plus alpha divided by 1 minus alpha, because beta is equal to, from the relation between beta and alpha we have beta is equal to alpha divided by 1 minus alpha. So if you make the addition, then gamma will be equal to 1 divided by 1 minus gamma alpha. So this is the relation between gamma and alpha. So you can remember, you have to remember this relation, that is gamma is equal to 1 plus beta, that is equal to 1 divided by 1 minus 1 minus alpha, and this is the well-known formula, and you have to remember this formula between alpha, beta and gamma, and a problem will be asked to you from this formula.